Okay, so I think we can get started. I hope you're all set up and ready to go for the next 20 minutes-ish, maybe less if I get too nervous and start talking like Speedy Gonzalez runs. If you don't know who Speedy is, here's a GIF for reference. Today I'll be introducing you to FrontEnd Security. Hopefully not everyone is a master in this, and most of you weren't at Drupal Hack Camp last year, as I would really love for you all to leave here with a little more information than what you came in with. For those of you who were in Bucharest last year, well, this will feel like a rerun. So this is me, Madalina Cotumbeanu, Maddie for short. I'm a senior front-end developer at Softescu. I have been working there for the past 5 years and a few months. I started as a junior front-end developer, and with the patience and guidance of my colleagues, I bloomed into the developer that I am today. I'm also a Drupal 7 and Drupal 8 certified developer, and this is my second time speaking in front of a largish audience. Okay, now I feel like we got a little bit acquaintance, so we can get down to business. What do you think of when you hear security in web development? Anyone want to have a go at it? No? Okay. Well, the majority of us would be tempted to pin the security issues on the back-end developers, on the DevOps, and from a front-end developer's point of view, we might even pin it on the QA department just for the fun of it. Teach them to say, not according to the design. We don't do security. We're mythical creatures that take the designer's vision and the backend's implementation, and we make all of that look pretty for the final user. We make it easier for the user to access our information with style. We make everything look flashy. Well, yes and no. I mean, we're indeed mythical creatures, there's no doubt there, but we also have the same level of responsibility when it comes to securing our web pages, just like everybody else. The number of attacks on websites have increased over the years, and the internet has become somewhat of a dangerous place. We all heard of the famous cases where millions of personal information have been leaked to the public. Sensitive information like email addresses, passwords, social security numbers, credit card details, and such were entrusted with them by our users, and we're responsible for securing it as much as possible. The purpose of website security is to prevent these or any sort of attacks. More formally, website security is the practice of protecting websites from unauthorized access, use, modification, destruction, or disruption. Securing our websites requires a combined effort across the whole website, in your web application, in the configuration of the web server, in your policies for creating and renewing passwords, and in client-side code. While it's true that the user data is stored on the server and accessed through the backend, the same data is ultimately retrieved and displayed in the front-end application, creating an excellent opportunity to steal it. A front-end vulnerability happens when someone is able to harm your website application or users without even having to gain access to a server, a database, or hosting provider. So today we will try and understand where threats come from and what we can do to increase our protection for our web application against the most common attacks. Some common attacks that we're going to look at are SQL injection, cross-site scripting, and cross-site request forgery. And then we will look a little at some other threats. SQLI, we're going to take a look at this first. This happens when an attacker is able to execute arbitrary SQL statements on a database through a web form, field, or URL parameter, making it possible for them to gain access and manipulate said database. They can access data on the server, create new identities that have administrator rights, or just destroy or modify the data to make it unusable without even taking into account the user's permission. The Open Web Application Security Project rated the #1 attack on their OWASP Top 10 as being the SQLI in both 2013 and 2017. In 2007 and 2010, SQLI was a threat, but as we can see, it has gained popularity in the past years. Hacksplaining said that if you only have time to protect yourself against one vulnerability, you should be checking for SQL injections vulnerabilities in your code base. There are 4 forms of SQLI: incorrectly filtered escaped characters, incorrect type handling, blind SQL injection, and second-order SQL injection. Let's take the first one, incorrectly filtered escape characters. This means that a user's input was not filtered for escaped characters, letting it pass an SQL statement, making it possible to manipulate the statements performed on the database by the end user of the application. Let's consider the following query, where we're pulling up records of the specified username from its table of users. However, the username variable can be used by a malicious user in order to have the SQL statement do more than what the author intended. For example, setting the username variable as that will make the SQL statement look like this, and our statement will render. 1 does in fact equal to 1 always, so this is giving the attacker the possibility of adding additional queries at the end of the statement, queries that will be executed. Another example, let's take the previous statement once more to see another way that the statement could be misused. Again, we have a list of users with a particular name, and that name has been supplied from an HTML form. While entering a real name will have no side effects, an attacker could change the behavior of the statement to the following. We see here that the text after the first equal sign above was used as the username. The statement deletes the user tables and selects all data from the user information table, thus showing all the user information. This works because the first part of the injected text, n semicolon, double quote, you understand, completes the original statement. This sort of attack happens because we didn't make sure that the data that was to be passed to the SQL query will not change the nature of it. A solution is to escape all special characters in the user input that means something in SQL. If in our example we would have escaped the character single quote by putting a front slash in front of it, we would have treated the name as part of the string, like that. So now we will have a weird name as the whole string, but it's a string nonetheless. Web frameworks will often take care of this escaping for you. Incorrect type handling occurs when a user input field is not strongly typed or is not checked for type constraints. If we will have a statement that uses a numeric field, but we won't make checks to see if the user did input a numeric value, we will just enable an attacker to add a string. Because the programmer meant a variable to be a number but didn't check for it, an attacker could just add the following input, and this will drop all the users from the table. Blind SQL injection. I'm guessing this is very obvious, but I'll say a couple of words about it. This is used when a web application is vulnerable to an SQL injection, but the results is not visible to the attacker. The page with the vulnerability may not be the one that displays data, but will display differently depending on the results of a logical statement injected into the legitimate SQL statement called for that page. This has been considered time invasive because a new statement needed to be crafted for each bit recovered, and the attack may consist of many unsuccessful requests. Recent advancements, though, have allowed each request to recover multiple bits, allowing for more consistent and efficient extraction. Second-order SQL injections. These occur when submitted values contain malicious commands that are stored rather than executed immediately. In some cases, the application may correctly encode an SQL statement and store it as valid SQL, then another part of that application, without controls to protect against SQL injection, might execute the stored SQL statement. This attack requires more knowledge on how web application security scanners would not easily detect this type of SQL injection and may need to be manually instructed where to check for evidence that is being attempted. Before we try to understand cross-site scripting, let's take a look at the basic concept of same origin policy, or SOP. SOP means the websites are not allowed to retrieve content from pages that are not within the to read or modify data from a Facebook page, for example, while logged into them. This is what an origin is made of: a scheme, a host name, and a port. If any of these is different than what we're talking about, is a different origin. This is a very important security principle. To better understand, let's take like a sort of example. The page https example.com/index.html can access content from https example.com about HTML, while https attacker.com/index.html will not be able to access content from https example.com about HTML. Cross-site scripting is a way of bypassing the SOP concept. It is basically an attack that allows malicious users to inject client-side scripts throughout the website into the browser. By doing so, the attackers can do things like read data, such as the set cookies. They can access other pages within the same domain. If the user's site authorization cookie, they will be able to log into the site impersonating the user and do anything the user has be able to access credit card information, contact details, or they might be able to change the password. If they don't get to log in as the user, they might still read private details and make requests on behalf. An example could be, we have a website where we enable the comments without the proper validation. An attacker could submit user's browser and steal the login cookie, making it possible to take control of the accounts of the users that viewed the comment. XSS vulnerabilities have been more common than any other type. There are two main types of reflected and persistent. Reflected occurs when the user content that was passed to the server was returned on the page without being stored. The script will be run when the new page is loaded, so when the user clicks on a link. Let's take the confused deputy problem. A program which is tricked into misusing its authority is a confused deputy. Basically, you're tricking someone into doing something that they're not allowed to, that they are allowed to, but you aren't. I'm going to deviate a little bit here, but I want to make sure that we all get what this means. An example of this would be to see the military's defense plan of Catopia. Now, normally, George would fetch the plan only if the Cat General of the Army asked him. You want to have a peek at that information. What you do is you gain George's trust, and then you tell him that the general asked you to get the plan for him. So do we know who the confused deputy is in our example? It's George. Let's say George is now passionate about adopting. Looking at a shelter site, he sees an ad. Looks something like that. I'm guessing that might not be making much sense. The decoded URL. We now see that the search parameter has an HTML script tag that might be trying to steal something. That vulnerability happens when the script is not visible. When it is printed, allowing an attacker to insert scripted code when creating an account. The username could look something like this. The code is triggered users for the attacker. This kind of attack is very popular and powerful as the attacker is not required users. We need to make sure that no one other than what we wanted. Content Security Policy, CSP, can also help in these kind of attacks via an SAP header. HTML code. A CSP header JS that is executed on the page. With this, on our domain to run, this allows inline JS and so on. Cross-site scripting defense. We should only allow trusted origins required for the applications to work and deny anything else. If we would have used, the evil script wouldn't have been downloaded. Another good practice is to avoid loading scripts, images, styles, and other assets from any other origin except from the server. If one of those sources gets compromised, the loaded script may contain harmful code. The best defense against XSS vulnerabilities is to remove or potentially contain instructions, HTML tags like script. The process of modifying users' data so that it can't be used to run scripts or otherwise affect the execution of secure code is known as input sanitization. Many web frameworks the user and take over the account. If the user has administrative rights, it might alternative to sanitization. Attacks allow an attacker to execute actions using credentials of another user with example with George, who is now a logged in user on the site via a stored cookie. A cross-site request forgery attack. The browser is the confused deputy in this case because storage and so on. So any scripts running inside the app will have access to these site can issue requests to your bank using your browser. To the user's cookies, the browser clickjacking. In this attack, a malicious user hijacks clicks meant for a visible top-level site and routes them to a hidden page beneath. This technique might be used, for example, to display a legitimate bank account site, but capture the login credentials into an invisible iframe controlled by the attacker. It could alternatively be used to get the user to click a button on a visible site, but in doing so, actually unwittingly. Directory traversal, file, and disclosure is a type of attack a malicious user attempts file system that they should not be able to access. This vulnerability occurs when the user is able to pass file names that include system file navigation characters. The solution is to sanitize input before using it. File inclusion is the attack a user is able to specify an unintended file for display the web server or in the client side, leading to an XSS attack. Input before using it. Command injection attacks allow a malicious user to execute arbitrary system commands on the host operating system. The solution, again, is to sanitize user input before it might be used in system calls. Been giving a few prevention tips throughout the presentation, but let's put it all together. Here are some of the best practices that can help us minimize the risk of such attacks happening. Filter sanitize all request parameters and inputs. This is done by escaping all characters that can so that the script tag is returned, as you can see in the parentheses. We do have built-in sanitization features or plugins that help with keep development frameworks and libraries you use up to date. This will help you take full advantage We might even implement workarounds and hacks. Things like these are usually the culprits of many security applications. Ultimately, you want to stop users from being able to execute any file they upload. Some options are to rename the file name or to change the file permission so that it cannot be executed. Preventing unwanted characters from being passed to the such as greater than, smaller than, semicolon. Only letters and numbers, plus anything else that is specifically required or characters that you actually lead to problems. For example, %3b is the hex code for a semicolon. So if b instead. Correctly applied URL encoding is necessary. Links should generally be sandbox attribute. This will prevent iframes from running, navigating the window, showing pop-ups, and so on. We could allow some of these by adding specific values inside the sandbox attribute. Other concrete steps use more effective factor authentication for your site, so that in addition to a password, the user configure your web server to use HTTPS and HTTP strict transport security. This encrypts data sent between your client and server. This ensures that login header informations are all much less available to the attackers. Keep track of the most popular threats and address the most common vulnerabilities first. Use vulnerability scanning tools to perform automated security testing on your site. Nikto, Qualys, Sucuri, and security headers, and so on. Only store and display data that you need to. For example, if you're using enough of the card number that it can be identified by the user, and not enough that it can be copied by an attacker and used on another site. The most common pattern here is to sum it all up, front-end security's flaws are mostly the results of tricking some components to misuse their authority. The technique to do that can be unexpectedly smart, hard to foresee, but some actions can be taken to limit the side effects. All sites have holes. What we can do is ask ourselves, when will they be exploited? And how can this piece of code be tricked to misuse its authorization? About website security is to never trust data from the browser. This includes GET requests, data and URL parameters, post data, HTTP headers, and cookies. Always, always assume the worst. These are some of my main places where I got my information from. And if you have any questions, so there's one. Loads of information, thank you very much. Using the blank attribute on link tags in HTML is now deemed unsecure. Which part of vulnerability does that open up? Link tags. I think that opens us to be honest, I don't really know. I'm going to have to check because I don't really know. But I'm going to check and I'm going to come back to you. If the one who answered this question can come to me, I'll check and I'll answer it to you. Okay, so thank you all for your patience and presence. Hope you all have a nice day. Enjoy the
We have a question.
Oh, okay. Sorry.
Yeah, I'm a little bit helping you. It's called open redirection. You don't hear.
I didn't hear what
Okay.
you said.
If I don't talk to the mic, you hear me better?
I'm going to come to you because I don't.
Okay.
I'm a bit deaf.
Okay. Let's use the mics and everyone in the building listens to us. So basically, that vulnerability is called open redirection. Okay. And I have a question, so not about that. What would you say if someone attacks only the front end when it is decoupled? So it it is not coupled with, for instance, Drupal or whatever backend, but it's fully decoupled and only attacking front end, such as a React application. What are the possibilities? He might inject things via APIs.
That's a good question. And I'm going to have to actually look into that as well because I've never actually worked with decoupled. This is something new for me. So this is only like research I've done for not decoupled. But I'm going to look into it. Again, give me your email address and I'm going to come back to you.
I will.